Naming the compounds of polyatomic ions, it's the same rules for the binary. Binary is 2, so just like sodium chloride, it's going to be the same thing with polyatomic. We're going to name the cation, and that might be a polyatomic. And if the cation is transition, we're going to put a Roman numeral in front of it to indicate the charge. Then we're going to name the anion. And the anion might be the polyatomic, so then we'll name the polyatomic. Now the rest of this video is just going over practice, so I recommend just trying it with me or trying it ahead of me, pausing it and seeing how you do. If we try these, you can have your list with polyatomic by you, and then try them later again. So I'm just going to read them off. My pen is it's kind of hard to write with this. So this one is sodium acetate. That's the acetate. This next one is magnesium oxalate. So remember the cow. Ox also spells cow. Ox is kind of like a cow, and that's what this spells, cow. Aluminum phosphate. Now this is our first, so we have to really recognize this is our first positive polyatomic. Ammonium, and then it's chloride. Ammonium over here, and now we have 2 polyatomics. Nitrite. Ammonium nitrite, 2 polyatomics. Here we have lithium sulfite. And you probably can hear in the background, as I list the polyatomic ions, there's a lot of excitement around. We were just doing a little electron configuration and a lot of excitement with that. That just doesn't end. Calcium hydrogen sulfite. And notice even though the charges are different down here, it's the base that we're looking at. Aluminum, we look at the base here, chromate. And when we get to doing the formulas, we'll see that they act as one ion, so it doesn't really matter that there's 3 of them. It's still just 3 chromates. So here's going to be more challenging because we have silver. This is transition. We have transition metals with polyatomics. And we have silver and nitrate. So that means we just can't call it silver nitrate. We're going to have to use Roman numerals. We have to do just like the laws with the binary compounds. We're going to have to use the negative charge of this one. So this is going to be NO, and it's minus. So we have a silver. What is silver going to be? To balance it out, we're going to have silver plus 1. Just going to be 1. So if it's 1 plus, it's silver 1. Silver 1 nitrate. What about this one? Now here it might seem a little, oh my gosh, it just seems amazingly difficult. It's just complex, but all this is saying there's 2 groups of NO3. So we have silver, and there's 2 groups of NO3. That's all it says. Now what's the total charge on 2 groups of NO3? 1 is just 1 negative. 2, so it's just like the ions we did before, but now we just have these. Just treat these as a group. Just treat these as 1. Okay? You just treat them as 1. So we have 2 minus here, total of 2 minus. So this one is going to be 2 plus because there's only 1. If this is 2 plus, it's silver 2 nitrate. Some people may have a hard time thinking, well, how do we know that's polyatomic? Well, the silver is just going to bond with 1. We really just have to get in the habit of recognizing. That's why it's important to know these. Just to recognize that NO3 is polyatomic. Only time you'll have a parenthesis around it, like in a group, is if there is more than 1 of the polyatomic. We have to recognize that this PO3 down here is a polyatomic ion. PO3 is a charge of 3 minus. So silver, if it's a 1, just 1 silver there, that must have a charge of 3 plus to balance it out. If it's a 3 plus, it's silver, 3 phosphate. Now let's look down here. The phosphate again is PO3, 3 minus. There are 3 of them. So if there are 3 of them, each must carry a charge of plus 1. There must be 3 of these. Silver 1, phosphate. Beryllium is 2 plus. Nitrite is NO2 minus. We'll put them together and we do it just like we did those other ions. Make this as like it's one atom or one element. It just goes as a group. So it's going to be BE parentheses NO2 2, because we need 2 of the nitrates. We need 2 of these to balance it out. Barium is Ba2 plus. Sulfite is SO3 2 minus. So look, it's a 2 minus to 2 plus. It's going to be BaSO3, and that would be it. How about magnesium carbonate? Magnesium is Mg. Also 2 plus. Carbonate is CO3 2 minus. Well, that's just going to also be a 1-to-1 relationship. Magnesium carbonate. Again, this is just a group. It's just one. Just a group that acts as one. Lithium is plus. Dichromate. Dichromate is DiCr2O7 2 minus. Okay, so we have Li. We need 2 of these. And we have Cr2O7. Aluminum phosphate. Aluminum is Al3 plus. Phosphate is PO4 3 minus. And it's a 1-to-1 relationship. AlPO4. You know, you do need to be aware of the charges. It's not, you just don't put them together. Some of them work out, like this one, where you just can put them together. But others, like the first one and the lithium dichromate, you have to make sure you have the correct amounts. Aluminum cyanide. Aluminum, again, is 3 plus. Cyanide is Cn minus. So that's going to be Al parentheses around. So we're going to need 3 cyanides. 3 cyanides because we have 3 charges. It's just like the regular ions. Cn3. Okay, what about aluminum nitride? Now I put this in as a little trick. Aluminum is 3 plus. Nitride, that's not polyatomic. That's just the nitrogen because it's IDE. So be wary of that. IDE as opposed to ITE. ITE or ATE. IDE is just N 3 minus, so that's ALN. Little trick there. Okay, so some more practice. We have ammonium NH4 plus. We have to recognize that name, and fluoride is F minus. So that's just going to come together in a 1-to-1 relationship. So it's NH4F. Ammonium fluoride. Ammonium hydroxide, well, what is ammonium? It's a plus. Hydroxide, need to recognize that, is OH. And that also is a 1-to-1 relationship, and we have NH4OH. Ammonium permanganate. MnO4 minus. That's also a 1-to-1 relationship. NH4 MnO4. And what about calcium phosphite? Calcium is 2 plus. Phosphite is PO3 3 minus. It's the same like we've been doing though. You can just switch these two numbers. So the calcium will have 3 and the phosphate will have 2. So remember to include the whole group. Some people will just they'll do this, they'll do PO2 because it's 2 of them, but remember this PO3 acts as one ion, one element, or basically, so it's PO3, 2, calcium phosphate. Okay, the fun even gets more fun and more challenging. The tin, we're going to use transition, we see with the Roman numerals, tin, 4, that means it's a 4 plus. The perchlorate, so remember per means more, so there's more oxygen. So if you can just ClO, if you can remember the chlorates go from 1, 2, 3, 4. The hypochlorate is the 1, the hypochlorite is the 1, the chlorite is the 2, the chlorate is the 3, and the perchlorate is the 4. And that had a charge of minus. So we're going to have tin. We're just going to switch these numbers again. So there's just one tin. We have to put the parentheses around the chlorate or the perchlorate. And that has 4 of them. How about tin 3? Tin 3 plus, the perchlorate is ClO4 minus. You can just switch the two numbers. This goes there. This will go here after the parentheses. So we have tin chlorate 3. Tin 2 is SN2 plus. The perchlorate is a ClO4. Here in the background, people are excited about electron configurations. ClO4 minus. And so we have SnClO4 2. We're just swapping them out. The tin 1. The perchlorate ClO4, again just minus. It's a 1-to-1 relationship, so we don't need parentheses. We just have perchlorate. So that's tin 1 perchlorate. We have the nickel silicate. Nickel 1, that's Ni plus. The silicate is the SiO3 2 minus. And just swap those two numbers. Ni2 parentheses. Actually, we don't need parentheses because there's only one silicate, SiO3. How about Ni2? It's Ni2 plus silicate. Same thing, SiO3 2 minus. Here we have a 1-to-1 relationship between the nickel and the silicate. Ni, again, SiO3. Nickel 3 is Ni3 plus O3 2 minus. Switch those two with each other. So we have Ni2 parentheses. Now we have to use parentheses here. SiO3 3. If we had nickel 4, Ni4 plus silicate, same thing. So we're going to swap the two numbers with each other. It's going to be Ni2 parentheses SiO3, and there's going to be 4 of them.